Okay, today we're going to be talking about converting from vertex form into standard form and then converting from standard form back into vertex form. This is useful because vertex form lets us easily see where the vertex is. Our vertex is at whatever this h is here and whatever this k is here. Standard form is useful because it's the simple standard normal way you're going to see a quadratic. It's also what you need it to be in before you can apply the quadratic formula. Though from vertex form there are other tools we can use to solve our problems. So first we're going to look at converting from vertex form to standard form. And this is actually pretty easy. All you have to do is simplify what you're looking at. So we have, for example, f of x equals 3 times the quantity of x plus 2 squared plus 5. We start by just doing the FOIL in the middle there. We get x squared plus 4x plus 4. And then we go ahead, multiply through by 3, add 5, and we come to 3x squared plus 12x plus 17. So if you didn't follow there, my 3 got multiplied by this 4 here, which gave me 12, plus 5, which gave me that 17. So, looking at the next problem here, we have f of x equals 2 times x minus 3 quantity squared plus 4. We're going to do the same thing. We'll start by taking x minus 3, doing it times x minus 3. So I'm going to get x squared minus 6x plus 9 plus 4. And then I'm going to go ahead and wind up with negative 2x squared plus 12x plus 14. So, that was one direction. Now for the other slightly more complicated direction. Now what we want to do is convert from standard form to vertex form. And our first problem is going to be f of x equals 5x squared plus 40x plus 74. I'm just going to go ahead and put over here on the side one of the problems we did a second ago so that we can use it kind of as a reference. So what we're trying to do is go backwards from here to here. So we can kind of use this as a guide to figure out where we want to be. The first thing I kind of notice here about my two forms is that A is the same in this form as it is in this form. So we know we're going to have a 5 in front here. Okay? What I'm going to go ahead and do is pull the 5 out of just the first two terms. So the x squared term and the 40 term. The problem is that this 74 here is going to be a composition of the a times this plus whatever this winds up being. So it's not going to divide cleanly. So I can't just pull it out of there. So now we're one step closer. This looks a little bit more like this over here. What I'm going to do now is I want eventually to get this into something that looks like this that can be turned into something here that is something quantity squared. So I'm going to need to add something like this 9 here to the end here so that I can factor it. And in order to figure out what that is, I want to take a look at just like what happens if I do something squared. So I've got m plus p here, and I want to do m plus p quantity squared. I FOIL that out. I get m squared plus 2 times m times p plus p squared. So my 8x term here is like my 2mp term here. So my 8 is kind of like 2 times p. So I can use that fact to figure out what to put in here. So I've got 2p is equal to 8, which means p is equal to 4, which means what I want to have on the end there is going to be p squared, or 4 times 4, it's going to be 16. So I'm going to go ahead and just stick a 16 in there. I know I want it to be there, and we'll get to making this mathematically valid in a second. So x squared plus 8x plus 16 is the perfect square x plus 4 quantity squared. So now we're going to be able to reduce this into something more like this. that's good. But I just kind of stuck 16 in right here without any kind of balance for it. And we're not allowed to do that. So what I need to do is figure out what I really did to the problem. I stuck the 16 in here, but that's inside these parentheses, and these parentheses are being multiplied by 5. So 5 times 16 is 80. What I really did is I added 80 here. And I'm going to counterbalance that by subtracting 80 on the outside. So I added 80 here, I subtracted 80 out here. That's a total of 0. Then we're going to say this simplifies to x plus 4 quantity squared. And it's always this value right here, right? Goes back to this right here. So this is always going to be whatever you had here. It's that x plus that squared. And then negative 80 and 74 are going to combine to give me negative 6. And that was a little quick there. Okay. So that's going to combine to give me negative 6. So this is our first example of completing the square. The reason we call it completing the square here is here we had x squared plus 8x. This is part of something that we wanted to be some perfect square, like x plus 4 squared. And in order to complete it, we had to add this 16 in here, which we had to balance by subtracting this 80 here. And that's the process of completing the square. So, one more example. Okay, we're going to move from standard form to vertex form, negative 2x squared minus 12x minus 13. I'm going to start the same way I did before. I'm going to pull out that a value from the first two terms. And again, I'm only pulling out from the first two terms because negative 13 is going to be like this 14 here. It's this times this plus whatever this is. And since I don't know what this is yet, I can't pull it back out again. So I'm just going to leave the negative 13 on the outside, and it'll work itself out through the course of the problem. Now, in the middle here, I've got x squared plus 6x. And I need that to be some sort of perfect square, something I can factor into something like x plus 7 quantity squared. So I need a final term on here. Now, strangely enough, this is very similar here. This is x squared minus 6x plus 9. So that gives us an idea of what we're looking for. But I'm going to go through it the rest of the way. 2p is going to be equal to 6, so p is going to be equal to 3, so p squared is going to be equal to 9. So I stick a 9 in there, but in order to stick a 9 in here, which is being multiplied by negative 2 times 9 is a negative 18, so I've stuck really a negative 18 into my equation. I have to stick a positive 18 on the outside. And then it's a simple matter of this factors, x squared plus 6x plus 9 becomes x plus 3 quantity squared, and 18 minus 13 becomes 5. And this is now in vertex form, and we're done.